Welcome everybody to my channel. This is Senior Developer in 24 Hours. This is part 13, stubs, mocks, and more tests. My name is Andres, and we're going to continue our discussion about integration testing and how we can actually implement some useful integration testing. Thank you for joining me, and let's get going. All right, so what is the main takeaway of this video? The first thing we're going to take a look at is how can we actually implement stubs. When we have a dependency that we need to fulfill, how can we actually write something to replace that dependency if we cannot use the real component because it's too expensive, because it is not available, etc. We're going to finish looking at the steps that we can use to write effective integration tests. And finally, we're going to learn about some aspects that we can test with our integration test. After we built all of the infrastructure, after we built all of the boilerplate to get an integration test running, there's a lot that we can do. We can leverage this functionality to do some really cool stuff. All right, so let's review real quick, what are the steps in which we can break down the big task of creating an integration test so that, we can solve it piece by piece. First thing, we want to define the scope of the integration test. We want to determine the objectives of the test. What are we trying to achieve? We want to identify the dependencies. If we're talking about an integration test, we're talking about a test that is comprised of at least two components that are talking to each other, and most likely, they're going to be dependencies that are going to have to be identified, and we're going to have to deal with them. We're going to design the tests. We're going to actually write the test scripts. We're going to implement any needed stubs for the dependencies that we have previously identified. We're going to talk about how to set up the testing environment, how to execute the tests, and how to evaluate the results. In the previous session, we've already covered the first 5 of those. So today we're going to dive right into implementing any needed stubs. And at the end of the day, big part of integration testing is dealing with the dependencies. Always, the closer we are to production, the more similar it looks to production, the better. However, we're going to have to figure out how to fulfill the different dependencies because it is pretty much impossible to always have the same environment that we're going to be running in production. So we'll have to work around those things. We can be dealing with internal dependencies. If we are talking about internal dependencies, we're basically talking about modules that are not ready to be tested. So, we can leverage stubs for this. We can leverage them as code within the calling component, or potentially they can be standalone services so that they can be called by different components. And we're going to take a look at those two types of stubs real soon. And obviously, as we work through the process, we want to remove the stubs because, we're getting these internal dependencies loaded into our stack. So we're moving closer and closer to our end state. External dependencies, again, the closer to production, the better. If possible, we want to use the same component. We want to use the same database. We want to use the same messaging system. We want to use the same API as in production. However, we want to make sure that we can get that system into a known state. Also, we want to be aware that using shared components will limit how many test suites we can run in parallel, so something to be aware of. However, sometimes it is not really feasible to use the actual external dependency, so we'll have to use an emulator or a stub. And the techniques that we're going to talk about now are going to help you get there. All right. when do we need to create a stub for an external component? When we don't have access to a real component. Sometimes it happens. Sometimes we cannot get it to behave in a predictable way. Sometimes it is too expensive for us to use. So, in those cases, we can create a stub. And the first example, we're going to be using Noock to create a stub inside our custom component. Okay, now let's take a quick look at how we can mock an internal interface to an external API that we might be missing, that might not be available, situations like that, how we can mock that from within our code base. And for this, we're going to use a small Node application. We can see the application here is a basic Express application where we have a single endpoint, and this endpoint is getting a request from api.mymissingmodule.com, which obviously is not implemented anywhere. And the API is very simple. We basically fetch the data from this external API and we return it back to the caller. So if I were to run this application, it is obviously going to fail because it has nowhere to connect to. Obviously, we can wrap this around with some better error handling and things like that, but for the fact of the matter is that we are getting no response. All right, so how can we make this work? How can we test our API before this third-party API is available, or how do we get around the fact that it might never be available to us during our integration testing phase? And we can leverage a Node library called Noock, which we can install. And now we can use this to basically mock calls to some arbitrary endpoints. So let's edit our application real quick. And by the way, Noock is normally used for unit tests, but in this case, we are going to use it for an integration test. Because we're going to use it for integration test, we are going to add the code as part of the main application, not in a separate file for unit testing, but in the main application. So we can add some logic here. Where we basically require the Noock library, and then we can use this to tell Node that whenever it makes a call to this particular host, and it is a get to this particular endpoint, which if you see here, the path here is going to match the path that we have here. And obviously, the method is also get. We're going to reply with a 200, and we're going to send a body that says, okay. And the last thing we're going to do is we're going to tell it to persist. By default, Noock is only going to send this response once. We can queue up multiple responses, but in this case, just for the sake of this particular test, we want to send the same response as many times as needed. And this is probably how we want this to look in an integration test scenario. So with that said, we're going to save the application. We're going to start it again. And now we're going to hit the same endpoint. And now we have a valid response. So in here we added a little bit of code, and we can now get this microservice, this small backend application working even before we have, all of the third-party dependencies or all of the other pieces of the system. Now, with that said, we want to make sure that the code that we added here is only executed when we are running our integration test. And as soon as those things become available, we want to remove this code. So, we have to do a little bit of hygiene to ensure that our code base remains clean. But this is a very simple mechanism in which, only using 5 lines of code, I can fill in for a missing API. And of course, this is all happening in process, so other processes will not be able to hit this missing API. But if we have an API that is only required by a single service, this might be a viable option. If we have a service that is going to be consumed by multiple of the components that we're developing, maybe we need to consider some other technologies to achieve this goal. Okay, and now we're going to look at a different example. Now we're going to use WireMock to create an external stub that can be called from multiple components. Now let's take a look at a case where we have a missing component that we want to mock, but we want multiple components to be able to access the same mock. Let's take a look at the very simple application that we were using to demonstrate the situation. Basically, we have a single endpoint that is going to fetch data from a component that is not available, and it's just returning that to the caller. So very simple, very straightforward, but this will help us, again, show how we can mock this missing API, in this case, in a manner in which it can be reused by multiple components. Okay, and for this, we're going to use a utility called WireMock. It is a Java application, but you can use it without any Java knowledge. You can also integrate it within your Java applications, but in this particular case, we're going to use it to test a Node.js/Express application, and we're going to do that without having to write any Java code. So with that said, we can start up the application. And by the way, there's multiple ways to start this up. Again, it can be started from Java, it can be started from the command line, it can be deployed as a Docker container, etc. And now we are going to configure this particular mock. And if you remember, we are basically just hitting we're hitting a path within our missing component called /health. We're just doing a get. So what we're going to do now, we are going to configure WireMock. We're going to configure this particular stub by sending a post request to WireMock. WireMock is running in port 8080, and we're going to add a new mapping, which basically says that whenever we hit the /health endpoint with a get, we're going to send a response of 200 and a body that says OK. So because WireMock is already running, when I run this, I'm going to get back current setup of this particular stub. Now I can start my application. Now, before I actually try to hit my endpoint, we have to keep in mind that the application is configured to hit api.mymissingmodule.com. This is a domain name that doesn't point to anywhere. So what I've done is I've basically configured it to resolve back to localhost. So because WireMock is running locally in my own machine, I want to have this particular hostname, come back to localhost so that wiremock can implement this missing component. And with that said, I can just hit my endpoint, which is running at localhost on port 3000. Port 3000 is the port in which my Node Express application is running, and I should get a response back. And with this, we basically have a mock that we can share among different components, as long as, it is available through the network. We can configure it relatively easy. We can do it through the REST interface, as we did here in this exercise, but it can also be configured again through Java. You can drop the configuration in the file system for wiremock to pick it up. So it's very flexible, and it allows us to very easily come up with a stub for a missing API. Now that we have all of our dependencies, let's talk about how we can set up the test environment. So what is the general idea? We want to bring the system to a known state. We want to ensure that the components are deployed, that we're using the right versions. We want to make sure that we're testing the right system. We want to ensure that the data is in the correct state. We might have to bring up any ephemeral infrastructure to support our test, databases, things like that. Normally, we want to leverage infrastructure as code tools. We can use things like Terraform to bring up a bunch of components. We can run our test, and then we can shut it down really easy to ensure that we're not spending money supporting an infrastructure that is not being used at the time. So what does that process look like? Very straightforward. Bring up ephemeral infrastructure, Terraform apply. If we're using something like Terraform, we want to ensure that we're deploying the right versions of our components. We would load any required data, we would execute the tests, and we would tear down that ephemeral infrastructure. So if we can follow that same pattern, we'll be able to replicate it across our different tests to be able to have a reproducible way to get accurate tests. Once we have all of our infrastructure, we can actually execute the tests. In the beginning, it might be just a manual thing where somebody goes in, we have an actual operator that clicks the button that says run, we execute the test. Again, it is important to understand that integration tests tend to be a lot more expensive to run compared to unit tests. So normally it is not viable to run them after every commit. It might be viable for something really, really small system, but for the most part, they take way longer to run, things like that. Sometimes, if we're using shared infrastructure, we might only be able to run one instance of the suite at times. So we'll have to work around all of those things. Ideally, we would have a single button or a single command where we can run this. We want to automate as much as possible, but not more than it is needed. Sometimes integration tests can be run nightly, and that's good enough. However, we want to remove as much variability from the system, so we still want to automate as much as we can. Again, all of the things that we were talking about, we want to integrate them using Jenkins, using Cloud Build, using whatever CI/CD tool that your team prefers. We can go through the basic steps. Ensure that the system is in the right way, in the right state. Ensure that any ephemeral infrastructure is deployed. Make sure we have the right versions of the components. Again, it depends on what the scope of your test is, what your overall objectives are, but sometimes you will run versions of the components that we know are working, except for one that we're testing the latest version to ensure that this new version of the component can work nicely with the other stable versions of the component. So step by step, we are mutating our system moving forward step by step in a way in which we can relatively painlessly identify when we have a regression. We want to set up the testing data. We want to test, we want to run the test in a controlled order to make sure that, it is reproducible. Once we have automated all of this, we evaluate the results. Hey, did they work? Did they fail? Again, if we're using something like JUnit or Jasmine, etc., it is really easy to evaluate if the results match what we expected or not. We want to document the results. We want to gather all of the results. We want to gather the evaluation of whether we passed or we failed the test. Ideally, we would export metrics to see if, hey, are we taking longer to run the test? Or are tests failing more than they used to? Things like that. We want to save detailed results in case we have to go and troubleshoot why something is failing. Not only do we want to save the results of tests that fail, but sometimes it is also useful to have detailed results of tests that succeeded so that we can compare them in case, they start failing. And ideally, we would make the results available for our continuous deployment system so that we can leverage that. We can feed that into the CD system to do things like continuous deployment, where, after we have cleared all of the quality gates, unit test, integration test, things like that, we are confident that we can deploy to production. All right, I mentioned this last time. This is pretty hard. And yes, it is hard. But the alternative of not doing anything is even worse. We're going to have regressions creeping in. Things that used to work, we fix them, then they break again. We're going to have a lot of wasted effort because we'll have to refactor the ways in which the systems interact because we didn't verify that the interfaces were properly aligned. So, a lot of extra work. We're going to, waste effort because we're going to end up with code that very likely doesn't really match the requirements that we had. We're going to have bugs that could potentially have cascading effects. Small bug here goes up or down the stack, causes a big issue. That could potentially cause an outage. And that leads to unhappy users. And nobody wants to deal with unhappy users. I don't. You don't. Integration test would make this a little bit less likely. So it is worth the work. With that said, it is important that the changes that we make, we make small steps at a time. And once we have a working integration test, we want to only change one component at a time, or maybe one test script at a time, or one stub at a time. That way, we're mutating things in smaller steps, and if something breaks, it's going to be a lot easier for us to figure out how to fix them. There are other things we want to test. For example, one of the biggest ones is, hey, can we handle errors correctly? Can we handle data that's not in the right format or data that's, somehow broken? Can we handle the failure of a component? And most importantly, can we handle a component coming back online? Can we recover from that situation? And this bleeds a little bit into chaos engineering, which is not really the scope of this video, but, it is important to see how things start to fit together and how we can leverage the infrastructure that we built for integration test, how we can use that for other purposes. For example, performance testing. Integration testing is not going to give us the whole picture, but it is a lot closer to production. And, as we start building that big stack, that big solution that we use to run our integration test, we can use that to test the system scalability and the ability to handle high traffic scenarios. So, we're going to go into a lot more detail on this, but these are things that we can build upon with the work that we do for integration tests. And of course, once we have set up all of this, there's other things that we can test. We already mentioned failures and errors and recovery, large amounts of data, high availability requirements, different device types and platforms, different networks conditions and bandwidths, different data centers and geographic locations, backup and recovery scenarios, disaster recovery scenarios, things like that. With that said, there's one more thing. Last video, I mentioned that unit tests are easier to write than integration test, except we're dealing with, very legacy code that is really hard to test. So in those cases, an integration test might be a good alternative to a unit test. If we have code that is really hard to test, hard to inject mocks at the source level, things like that, but we have interfaces, external interfaces that are well understood, it might just be possible that doing black box integration testing is more practical than creating traditional unit test. This is not a position where you want to be in, but sometimes when we have to deal with legacy code that we inherit, keep integration tests to the back of your mind. Maybe it can help you in a pinch if you're finding that writing traditional unit test is just not viable. All right, but what happens if all of this testing is slowing me down? Well, you want to identify which part of the testing is slowing you down. We want to ensure that we're testing meaningful user scenarios and user behaviors. Again, let's focus on critical user journeys. If we're creating integration tests, we don't have to test everything. We don't have to test every combination. We don't have to test every business rule. A lot of those things should be tested as a unit test. And the rest, we're testing it as we go here. Something else that is very important. If you run into any issues with your test, fix them quickly. If you have some of your tests that are flaky, sometimes they fail, sometimes they don't fail. All of those things are going to reduce the trust that you have in the system, and they're going to reduce the value that you get from integration tests. And finally, if integration testing is slowing you down too much, consider that there might be some things that you're doing as part of the integration test that are better suited for a unit test. As a senior developer, we should always be thinking, hey, should I be shifting this left? And, unit tests are quicker to run. A lot of times they're easier to write and maintain. So maybe that is the right approach to make your integration test easier to maintain and more useful. So in summary, hey, think about how you're going to test the code at the same time. Define the interfaces early on. Ideally, create the stubs or mocks to support integration testing. Start thinking about how you're going to implement this. Integrate and test early. And remember, this is a process, and it gets easier. The more you have, the more you build, the more you're going to be leveraging this, the more value you're going to get out of this. And in the next video, we're going to talk about code quality. We're going to talk about code formatting. We're going to talk about tools like static analysis that will help us make our code better before we even run it. Thank you for watching. Don't forget to subscribe. Follow me on X, Twitter. Follow me on Mastodon. Take a look at my webpage. Thank you, and see you next week.